Hey folks, welcome to the Chapter 6, Unit 8 review. Let's get started. Function and its inverse reflect over what line? They reflect over the line y equals x. All right, that was in your 6.6 notes, I want to say. Identify all transformations of f of x equals negative 3 times the square root of x plus 6 minus 7. So, if you have a negative on the outside, it is going to reflect, but it is going to reflect across the x-axis, okay? So if it's on the inside, it would reflect across the y-axis, all right? If there's a number multiplying on the outside, and it's bigger than 1, doesn't matter if it's positive or negative, just if it's bigger than 1, which 3 is, then it is going to be stretching, vertical stretch, okay? So I wrote vertical stretch by a factor of 3. If you're adding or subtracting on the inside, remember that kind of goes opposite. So this is going to go left 6. And then if you're going on the outside, that's not opposite. It goes up or down though. So this is down 7. And that's all there is to say about this one. So if I were to identify the transformations of this next one, by the way, I am in Chapter 6, Section 3 notes. You have a negative on the inside here, so that is going to reflect across the y-axis now. So if it's on the outside of the function, x-axis, inside of the function, and this is what it means by inside of the function, it's reflected across the y-axis. All right, and if you're multiplying a number on the inside, well then it goes opposite. So the opposite of 3 would be 1/3, and instead of saying a vertical stretch, you say a horizontal shrink by a factor of 1/3. Okay, so I know it's confusing, but just remember inside's opposite, and check those 6.3 notes for more details. So just to reiterate the point, I wrote horizontal shrink by a factor of 1/3. If it was a number like 1/4, it would be a horizontal stretch by a factor of 4. So it's like almost like a double flip, so to speak. But this plus 1 is on the outside, so this plus 1 is making it go up 1. If it was plusing 1 on the inside, it would be going left 1. But yeah, so let's see here. What else do we have to say? We're going to identify the domain and range for this function right here. So I encourage you to look at the graph, but looking at the function itself, if you're plusing 4 on the inside, you're going left 4, and if you're minusing 3 on the outside, you're going down 3. So my vertex, it's a quadratic function. You know that because of this power of 2. It's going to be at 0, 0, but the vertex is moving left 4 and down 3. So if you look at the graph, then the answer will become obvious. So I could tell you without the graph, but let's pull up a picture of the graph. So here you can see in red the original parent function y equals x squared, and then here's the new one. So any parabola, the domain is going to be all real numbers, and so the range is the thing that's in question. Normally it's y is greater than or equal to 0. But since you went left 4 and down 3, how's that going to affect the range? Well, it's the down 3 that's going to affect the range, and the range is going to be y is greater than or equal to negative 3, okay? So I know you went left 4. That's not really going to affect the domain because the graph is going to go right forever and left forever, so it's going to hit all the real numbers, okay? So that's pretty much all there is to say about that one. So in the next problem, we're going to calculate the inverse of the function we had. So if you're going to calculate the inverse, you're going to flip the x and the y and solve for y again. So I'm going to write x equals y plus 4 squared minus 3. And so I'm going to have to add 3 to the other side. All right, and so I have x plus 3 equals y plus 4 squared. And then I got to get rid of that square root. I got to get rid of that square, so I'm going to square root both sides. Okay? So remember, when you square root, you're left with plus or minus on the other side. X plus 3, they both got square rooted, equals y plus 4. So now I just need to get rid of that plus 4, so I can minus 4 to the other side. And so I'll write my official answer right here. And remember, instead of writing y equals, you say f of -1 once you find the inverse. F to the power of -1 of x equals, and you're going to write, if you have a plus or minus, that's going to go in the middle. So I'm going to write -4 plus or minus the square root of x plus 3. Okay? You see, all I did was just put the -4 in front. And that's the inverse of that function. With the next question, we're going to identify the domain and range of the inverse of the function. So I wrote down our previous answer, -4 plus or minus the square root of x plus 3. And remember, if you're going to type it in and look at the graph, you need to type it in. There's no plus or minus symbol in the graphic calculator, so you need to type it in as two functions, -4 plus and -4 minus. Okay? But remember, we just got the domain and range of the original. And inverse means it's flipping. So I'm just going to flip this answer, and I'm going to look at the graph to confirm it. But yeah, let's write down the answer of what I'm telling you it's going to be. So the domain and range, let's see, the domain was all real numbers on the other one, so that means the range on this one's going to be all real numbers. And the range on the other one was y is greater than or equal to -3, so this is going to be x is greater than or equal to -3. Okay, so that's without even looking at the graph, because I already did this. I just flipped that answer. So let's just look at the graph to confirm. So here's the graph. You can see how things flipped. See that vertex is at -3, -4, and see how the vertex was at -4, -3. And so what is the what are the x numbers doing? Well, it went all the way left -3, and it's going to the right. So x is greater than or equal to -3. And then it's going up and it's going down, so y is in all real numbers, see? So, like I said, so you can look at the graph of the original or the graph of the new one. If you look at the graph of the original, just remember to flip your domain and range answer. Okay, so for the next two, we're going to calculate the inverse of this function, and then we're going to find the domain and range of the inverse. So we need to get that answer, or like I said, we can look at the graph of this and reverse our domain and range answers. But let's start with doing the inverse first. So here, I'm going to rewrite it. X equals the cube root of 2y minus 6 plus 3. So the first step is to get rid of anything on the outside of the radical. So x minus 3 equals the cube root of 2y minus 6. All right? So how do you get rid of a cube root? You cube it. I'm always saying the answer as I pose the question. So you have x minus 3 cubed. You can just leave it like that. You don't have to expand it all out. Equals, and then we have 2y minus 6. All right? So I need to add 6, and then I'll have to divide by 2. So we're going to have some stuff in parentheses here. So let's see here. We have x minus 3 cubed, and then we plus 6, and then that's equal to 2y. So it's going to be all over 2. So we're going to go all over 2, everything, including that 6. So officially the inverse is x minus 3 cubed plus 6 over 2. All right. The only way you could simplify it is if you did, if you erased the plus 6 over 2, and you just wrote plus 3, because 6 divided by 2 is 3, and then you just let this over 2. Either one is acceptable, so we'll just leave it at like this since I just talked about it. But again, if you left it like it was up here, that's still okay. All right, so what we're going to do now is we're going to look at the graphs of each one. Okay, so what I did was I grabbed the original, that's in red, and then I grabbed the inverse, that's in blue, and so you get this cool looking graph here. And then in green, I graphed y equals x. Why did I graph that? Because in number one, I said, what's the line of reflection that splits a function and its inverse? And that's y equals x, and you can clearly see that here. It looks perfectly symmetrical about that line. So I said this in earlier videos, if you have an odd power, you're going to have an odd power or an odd root. You're going to have all real numbers because even though it curves, it's still moving up and still moving down. It's still going left. It's still going right. It's not restricted in any sort of way. So the domain and range are both all real numbers. And so the inverse of that is still going to be all real numbers. It's when you have an even root or an even power that you have a domain or a range that's restricted, okay? So, again, officially I just wrote domain is all real numbers, range is all real numbers. Let's move on. Here we're going to solve equations. So I have x plus 3 over 4 squared equals 16. So everything's in parentheses, so you can't get rid of anything inside of it until you get rid of the parentheses. Get rid of a square by square rooting. Again, if it was like a power 3, you'd cube root, power 4, you'd fourth root, power 5, fifth root, okay? But power 2, you square root. So you are left with x plus 3 over 4. And then remember, anytime you square root, you're left with a plus or minus answer. So you have plus or minus 4. So it's probably easier at this point to just solve it as x plus 3 over 4 equals 4. And then solve it again with x plus 3 over 4 equaling negative 4, all right? So how do you get rid of a fraction? You flip it and you multiply, right? But it's easier to just, I think, just do this. If you just have like something on top, like a statement x plus 3, for example, over 4, I'm just going to get rid of the bottom of the fraction, so you multiply by the bottom of the fraction. So I'll multiply both sides by 4. And so I know you're thinking, like, we're just back at 16. Yeah, but that's just how it goes. That's just because I chose a 4 in the original. So I'm going to do that to the other side here as well. I'm going to try and solve these at the same time. So multiplying these by 4 leaves me with an x plus 3 on each side. And then I have x plus 3 equals negative 16. And so then I have x plus 3 equals positive 16. All right? And so now I just have to minus 3. And 16 minus 3 is 13. So I get 13 for one answer. And then I minus 3 here. And it's not negative 13. Negative 16 minus 3 is negative 19. All right? So x equals negative 19. So it's going to have 2 answers on this one. Okay? Let's move on. Okay, so if you have 2 sets of like statements, binomials, whatever you want to call it, and they're raised to the same power, it's as if the powers don't matter. But officially, if you want to get rid of the power, you just raise but each side by the, what's it called, the reciprocal of it, and that would cancel out the powers. But you don't even have to really show that work, because if 3x plus 2 is raised to 7/8 and 1/3 x minus 4 is raised to 7/8, you can just skip ahead to setting them equal to each other, okay? So I wrote this down incorrectly, 1/3 x minus 4, there we go. All right, so now just solve for x. I see a minus 4, so I'm gonna plus it over to the other side. If you are canceling one thing on the right side, that means I must cancel one thing on the left side. So I'm gonna minus 3 over there. Okay, so 2 plus 4 is 6. And then you have 1/3 minus 3. If you were to write 3 as a third, that would be 9 over 3. So I have 1/3 x. You could type it into the calculator too, but I'm working here by hand. So I have 9 over 3 to get a common denominator, x. That was a weird looking 9, okay? So what's 1 minus 9? That's negative 8. So I'm going to write 6 equals negative 8 over 3x. So how do I clear this fraction? I'm going to multiply by negative 3 over 8. So you see, it's just a regular fraction. That's when I like to flip it and multiply. You could proceed by multiplying both sides by 3 and then dividing by negative 8, but this is quicker. So the answer is going to be whatever 6 times negative 3 over 8 is. 6 times negative 3 is negative 18. So you have negative 18 over 8, but that simplifies. They can both cut in half to negative 9 over 4. And that's as simple as it can get. I don't know what the decimal is on that one, but it's okay to leave it as a fraction. So negative 9 over 4 is my official answer. I'm just going to rewrite that 9 and see if I can get it better. There, that looks good. Okay, moving on. Here you have something under the fourth root, but you have something on the outside, so guess what? Minus 4 to the other side. So you have the fourth root of 1 over 3x minus 2 equals 44. How do I get rid of a fourth root? You do the fourth power. So 44 to the fourth power is a pretty big number, so I recommend typing that in the calculator. So I got this number, 3748096. All right, that's what happens when you just make up numbers and you're writing your own functions. So now I have to add 2 to it. So 1 over 3x equals 3748098. And so how do I get rid of the fraction of 1/3? I'm going to multiply both sides by 3. And so I'm going to get a really big number now. So I get, let's see, this is going to be 11,244,294, which is about how much I make in a year. Just kidding. But yeah, that's the final answer. So in this last one, we're going to solve it like normal, and then we're going to prove which solution will be extraneous. So that means when you plug it back in, it won't really work, okay? So you have x minus 10 equals the square root of 44 minus 2x. If you see a square root on one side, you must square both sides to get rid of it. So you have x minus 10 squared, okay? The quick way of doing this is to say, hey, what's negative 10 plus negative 10? You're always going to start with an x squared. Negative 10 plus negative 10 is negative 20. So negative 20x. What's negative 10 times negative 10? 100. All right? If that confuses you, x times x is x squared. X times negative 10 is negative 10x. Negative 10 times x is negative 10x. Added together, they make negative 20. And then negative 10 times negative 10 is positive 100. So that's going to equal just 44 minus 2x. So now I need to get everything to one side, and then I'll have to factor it. So I'm going to have to add 2x and minus 44 over, all right? And so that's going to leave me with x squared minus 18x plus 56 equals 0. Okay, so now I just need to think, what are the factors of 56 that add to negative 18? Off the top of my head, the first few numbers that multiply to get 56 are 7 and 8, but that doesn't work. So cut 8 in half, that's 4. If you cut 8 in half, you have to double 7, so that's 14 and 4. 14 plus 4 makes 18. So I'm going to say negative 14 and negative 4, add for positive 18, and multiply for positive 16. So I have x minus 14, x minus 4 equals 0. And so what number minus 14 equals 0? 14. What number minus 4 equals 0? 4. All right? So these are our two answers. If I'm going to show which of the two is extraneous, I'm going to plug it back in. I'm going to plug it back into the original, okay? Okay, so what I did here was exactly that. I plugged it into the original equation. So I plugged in 14 minus 10, that's 4. The square root of 44 minus 2 times 14 is 44 minus 28, which is 16. The square root of 16 is 4, so that checks out. Then I plugged in 4. 4 minus 10 is negative 6. Then the square root of 44 minus 2 times 4, that's minus 8. 44 minus 8 is 36. The square root of 36 is negative 6. So x equals 4 is extraneous because the square root of 36 is 6. Now, I know what you're thinking. Earlier in problems, every time we did a square root, we put a plus or minus, and that's true. But for problems like these, you only want the positive solution when you take the square root, okay? Because if you were to graph these, if you were to graph x minus 10 and then separately graph 44 minus 2x, it's going to look like this. The answer is where they intersect. They only intersect once, and that's when x equals 14. That's a y value of y equals 4, not an x equals 4, okay? So don't confuse the two, saying that they're both showing up. So yeah, x can only equal 14 where they intersect, okay? And that's how you show which one is extraneous and which one works, okay? So thank you for watching. Good luck on the test. Don't forget to write down notes on your note card. And goodbye.